Alright, let's solve this example. So we are to calculate the cell potential for the given system. So this is the cell notation representing the equation, overall reaction equation in a given voltaic cell. So we have here a copper as the anode and silver as the cathode. And we are also given the concentration of the copper ions and the silver ions in the solution. So the first thing that we need to do is to write the half reactions with their corresponding standard reduction and oxidation voltage. So for the anode and for the cathode, so what we're going to do is to find, so for the anode, it's the oxidation of copper. So this is solid copper, and that's Cu2 plus Aq plus 2 electrons. And then for silver, it's Ag plus Aq plus electron, producing Ag solid. And we are going to find from the table the standard reduction and oxidation voltage. So we have here copper reduction, and we have here copper reduction and silver reduction. So it's 0.339 and 0.799. So we'll just copy silver, which is 0.799. And for copper, because the given here is reduction, so we're going to reverse this, so this becomes negative 0.339. So negative 0.339 volts. So therefore, that's the first step, and then the next step is to find the standard cell voltage. So we're going to add the two, so that's 0.799 minus 0.339, and that would give us 0.46 volts. And then from the given equation, we can see that we have to multiply the second equation by 2 to balance the number of electrons. And when we multiply that by 2, we'll get the overall reaction. That's Cu plus 2 Ag Aq, and then that's Cu2 plus Aq plus 2 Ag solid. So we can see here that N, diba, ang number of electrons nga ma-equal na silang duha. So N is equal to 2. So these are what we need for the Nernst equation, right? So we need the cell voltage, standard cell voltage, and then N. And we also need to write this equation because we're going to need this for Q. So the next thing that we will do is to write the equation, Nernst equation. So Nernst equation is E equals the standard cell voltage minus 0.0257 volts over N ln of Q. So we already have E, which is 0.46 volts minus 0.0257 volts, and we already have N, which is equal to 2 ln of, okay. So unsa ln? So unsa may nasa product? So as you can see, this product is Cu2 plus, and then we have silver nga solid. So this is Aq. So it's just the concentration of Cu2 plus in the numerator. And then we don't need to raise it with anything because the coefficient is just 1. And then in the reactant side, we don't include copper because that's a solid, so we include silver. So the concentration of silver, that's Ag plus, and then we're going to raise that to the power of 2 because we have 2 here as a coefficient. Alright, and then we are going to substitute. So that's 0.46 volts minus 0.0257 volts over 2 ln of, and then the concentration, so we can see here from the cell notation that we are given the concentration of the copper ion in the solution, and that's 0.024, and then for silver it's 0.0048, and then we're going to raise that to the power of 2. And then after which you just have to input everything in your calculator. So that's 0.46 minus, but you have to be careful with the parentheses and everything else, because not all calculators have the same mechanism. Depende sa setup. Okay, so let's raise, and the answer is 0.37. So if we round it off to the fourth decimal place, that would give us 0.3707 volts. Okay, so the cell voltage under non-standard conditions is less than the cell voltage under standard conditions. Let's proceed. Example number 2. So, example number 2. Consider a voltaic cell in which the following reaction occurs. So we have this overall reaction, okay, in the voltaic cell. So we are to calculate the cell voltage E when oxygen is at 1 atmosphere pressure and the concentration of hydrogen and bromine, the bromide ions, are 0.1 molar. Okay, so just like what we did in the previous example, so the first thing that we need to do is to determine kung asay. So it's different, by the way. It's different because in the first example, we are given a cell notation, so we can directly identify the oxidation and the reduction reactions. But in this example, we still need to identify which species undergoes oxidation and reduction. But we already know how to do this. So in the case here, oxygen has an oxidation number of 0. This is positive 1, and this is negative 1. And then for hydrogen here, it's positive 1, oxygen is negative 2, and bromine is 0. So we can see that there is no change in the oxidation number of hydrogen. And for oxygen, there is a decrease in the oxidation number. So there is a decrease, meaning it undergoes reduction. And for bromine, from negative 1 to 0, so there is an increase, meaning it undergoes oxidation. So we look at the equation sa kadong table nato. So here we have bromine. We have the reduction of bromine, which gives us the standard reduction voltage of 1.077 volts. Nya pagkahuman, unsaon pagkaibaw ning isang equation? So unsa may naa dira? Naay oxygen, naay hydrogen, and then water. So you can just look for equations here. So mangita tag equation diri, hydrogen, oxygen, water, no? So muni siya, it will lead us to this equation. Oxygen, hydrogen, and water. So that's 1.229 volts. So we just copy that. So i-copy na nato diri, gibaliktad nato ang sa bromine, nya gi-copy nato diri, and then for the reduction voltage atong gibali, so that it would give us negative 1.077 volts, and then we simply copy the standard reduction voltage from the table for the reduction of oxygen, no? So that's 1.229 volts. So we add the 2, and that would give us 0.152. So let's check if that is correct. Okay, it's 0.152. And then in these two equations, we can see that there's 2 electrons here in the oxidation half reaction, and there's 4 here in the reduction. So we need to make the number of electrons equal, so we have to multiply the first equation by 2. So meaning, ang atong n ani diri, ang number of electrons na nga ma-equal sila kay 4. So diba? Again, for the Nernst equation, we need the standard cell voltage and we need also n. So writing the Nernst equation, so this is our Nernst equation, E is equal to the standard cell voltage minus 0.0257 volts over N ln Q. So, unsa si Q? Si Q is, di ba, products over reactants. So, ang naa sa products, ari tatanaw sa atong equation, or here. So, sa products, dili na to apilon si water. Ngano man? Because water is liquid, it's pure, so we don't include it. Diba? Solids and liquids. Bromine, as we can see, it's also liquid, so we don't also include this in the in the ratio, in the reaction quotient Q. So kung dili nato i-apil si water o dili nato i-apil si bromine, ma-zero. So no. So technically, functionally, we don't include them in the reaction quotient Q because their concentrations do not change. But it does not mean a 0. Pasabot ana class 1. So we just put 1 in the in the numerator. And then divided by, so as we can see here in the reactants, we have 3 species in the reactants. So we have a gaseous species, we have an aqueous solution, and then we also have another aqueous solution. So we all include them. So concentrations, hydrogen ion, and then we raise that to the power of 4 because of the coefficient. And then we have the concentration of the bromide ion raised also to the power of 4 because of the coefficient here. And then the pressure of the oxygen gas, so we don't raise it to the power of anything because the coefficient is just equal to 1. And then we just substitute whatever we were able to get na. So we have the cell voltage ng 0.152 volts, and then the 0.0257 volts, which is a constant, and then N is 4, so it's here. And then we just copy 1, and then the concentration of hydrogen is already given here. So that's 0.1 molar, and then we raise that to the power of 4. The concentration of the bromide ion is equal to that of the hydrogen ion, and that's 0.1 molar as well. And we also raise it to the power of 4. And then we're also given that the pressure of the oxygen gas is 1 atmosphere. So this equation, you simply input this in the calculator. So let's try if I want you to compute right now. I want you to get your calculator and I want you to solve. And let's try to check if the answer is really correct. Alright, so if you round it off to the third decimal place, it's 0.034. If you round it off to the fourth decimal place, that would give us 0.0336 volts. Okay, so that is for example number 2. And I hope you're able to get that.